Okay, so we're going to prove that sine of theta plus 270 is negative cosine theta, and cosine of theta plus 270 is equal to sine theta. So recall that sine of alpha plus beta, where alpha and beta are any two angles, is equal to sine alpha cosine beta plus sine beta cosine alpha, right? So instead of using alpha and beta, we'll use theta and 270. So sine of theta plus 270 is equal to sine of theta cosine of 270 plus sine of 270 cosine of theta. This is equal to, so sine theta is just sine theta. Cosine of 270 is 0, right? See, that's the x-coordinate, so it's 0. Plus sine of 270, that's the y-coordinate. This will be negative 1 times cosine theta. Now sine of theta times 0 is 0, and negative 1 times cosine theta is negative cosine theta. And that's what we did. So now let's move on to the next one. So remember, cosine of alpha plus beta is equal to cosine of alpha, cosine of beta, minus sine alpha, sine beta. So instead of using alpha and beta, we use theta and 270. So cosine of theta plus 270 is equal to cosine of theta cosine of 270 minus sine of theta sine of 270. All right, this is equal to, so this is just cosine theta. Cosine of 270 is 0, and then minus sine theta, and then sine of 270 is negative 1. All right, so now we have cosine of theta times 0 is 0, and then negative sine theta times negative 1 will be sine theta. So we have cosine of theta plus 270 is equal to sine of theta, which is exactly what we wanted to prove. So we've proven both of these properties of trigonometric functions involving any angle, adding 270 to it for the sine and cosine.